In this video, we'll talk about lines of best fit and correlation. So first, let's talk about lines of fit. So in a previous lesson, we talked about how we can fit, or maybe not fit, but how things might be associated with one another if we're looking at a scatter plot. So if we're looking at this scatter plot, a line of fit would be, okay, if I'm going to fit a line to this data, what would the best option be? I think we can all agree I wouldn't want to draw my line like this. That's not very close or very indicative of what is happening to this data set. It looks to me we have more of a positive association. So if we're looking at this, I think perhaps a better trend line would be to be going up and right. Now, again, this blue line seems to be better than the red line, and if I was to draw a green line, like so, I think the green line's better than the red line, but it's not as good as the blue line. The blue line is much closer to the data points. So a line of fit doesn't necessarily have to go through any of the points, but it's one that's somewhat close to what's happening. It's what we call a trend line. Okay, so if we're looking at a line of fit, we're looking more on a vague level. What's happening with our data? What would a line look like if I was to fit one that was somewhat close to this data? And then it would be useful for us to have that line so that way we can predict what's going to happen in the future. So what's going to happen out here. So now that we've talked about lines of fit, let's talk about this line of best fit. So if I'm looking at this scatter plot as an example, I can look at two potential lines. Let's look at a red line here and a blue line here. Now I think we could look at both of these and say both of these are fairly good lines of fit. There's not really a particular reason why one would be better than the other at what we know. However, this idea of how do we pick one that's the best. So what I'm about to show you here is more of a thought process. You would never actually do this by hand. We have machines to do that for us. So the idea is, if I fit a line, let's take a look at the red line first. If I'm looking at the red line, how I would do this is I would look at a data point and I would calculate the distance to the line. I would do the same thing with every other data point. And I would add up those distances. And then I would do the same thing with the blue line. I'm going to compare it to every data point. And I'm not necessarily going to draw each one, but I'm just showing you what it would look like on a graph. And the idea is whichever line has the smallest distance once I'm done totaling them all, that would be the line of best fit. So it's the line that is closest to all the data points. That would be indicative of our best one. Now again, this is something that you would never do by hand. This is something we would use a computer program for. The book has some questions about lines of fit, and it would make sense to talk about line of best fit. So before we end this video, this isn't so much something that the book goes into, but it makes sense to talk about it with what the lesson is going through. I want to talk about correlation. So correlation is a word describing that there is a linear relationship between two potential values, or that there is a very close to linear relationship. Now there's different ways of measuring it. The whole idea is using an R value, and the idea is that R bounces between -1 and +1 and 0. 0 being there is no correlation, meaning there's no line of fit that really makes sense. 1 being a perfect positive correlation, meaning that if I put my best fit line on a scatter plot, it will literally go through every single data point. And likewise, on the -1, this would be a perfect negative correlation. So this would be if I have a scatter plot and the line literally goes through every single dot. And there can be some in between. If I have a -0.5, that would mean that my line is going through, or maybe not going through, but it's close to a good portion of those points. So real quick, let's talk about some examples of correlation. If we're looking at a plot like this, we could put a potential line of fit going up. And it might not be a perfect correlation, but we can say there is a potential that this is a linear relationship between these two variables. This would be what we call a positive correlation. Very similar to an association. However, we're only looking at, can I put a line through this? Likewise, if I have something similar, this would be a negative correlation because it looks like there is something of a linear trend going down. And it might not be a perfect one, but we can say there is definitely something going on there, I would think. Similar to associations, if we have something where it is all over the place, I don't know what line I can put through this, so I'd say there's no correlation here, just like there's no association. And this last example will be where it'll show kind of the difference between the correlation and associations. If I have something that looks like this, there's definitely a pattern here. It just happens that it's not a line. So how do I put a line through this? Well, I don't. There's not one line I can put here that makes sense. So I would say there is no correlation. So correlation, just to put it in perspective, we're only looking at, can we put a line through this that makes sense? And it might be the case, like in this last yellow example here, where, yeah, there's definitely a pattern, it's just not a linear pattern. And in that case, I'd say there's definitely an association, but there is no correlation.